Welcome to my third live stream. Technical difficulties. I set up a link and prepared for a live stream, and well, I don't know what happened, but anyway, I couldn't get on. So I had to reset it up all over again, and here we are. So, apologies to the people who are waiting at the other one when you come back to this one. Yes, because of the screw up. I don't know what the technical difficulty is. I thought that having done 2 practice ones, that would be enough for me to know exactly how to use this live stream thing on YouTube. As it is, clearly I'm not an aficionado yet. So let's see how we go here. Hopefully I can be heard. I'm going to privilege the Patreons. You can become a Patreon of mine, of course. And the Patreons have asked me questions first, and then I'll get to the very many Twitter questions. So I'm just very relaxed here at the moment because I have a vast number of deep questions to get through. And so I could be here for a while. Now, Jem, my partner that I live with, suggested that I should set a timer so that way I don't go running over time. But I can imagine what I would do. I would see the 5-minute timer, let's say, and realize when the 5 minutes is up that I hadn't answered the question and have to reset the timer all over again. So I don't think that would help. And maybe just sitting back, relaxing, and taking my time with each of the questions, no matter how deep, is probably the best way to go. So, beginning with Mart Van Meegen from Patreon. He says, "Hi, Brett. I was watching competitive Rocket League recently, and it dawned on me that these professional gamers are doing things that the programmers could never have imagined when they made the game. That's undoubtedly true of many other games as well. I have a gut feeling it has something to do with universality, but I have no coherent thoughts. Maybe you do." Well, not beyond the fact that anytime a human being creates a system, which could be a game or it could be a method of printing, they could invent the pencil. Then, of course, any tool that a human being invents is going to be used by other human beings in completely unpredictable ways. And so, yes, of course, it has something to do with universality, the creativity of people. So an invention is going to be used by people in creative and different unusual ways. I mean, I played Skyrim there for a while, and people weren't simply playing Skyrim. I mean, they would gather there. Yeah, sorry, not Skyrim. What was the online? Anyway, online games in general, people use not merely to play the game, but to gather together and to even have parties and stuff and have meetups. And so, yeah, of course, I'm sure the person who invented the early systems of writing may not have imagined all the different uses that writing would then be put to. Possibly it was just used initially to record messages or to record official documents, let's say. Who knows if they would have been able to imagine scripts for movies and that kind of thing. So same kind of thing. Someone invents a game, and the users of the game, the players, are going to come up with interesting things to do that the programs could not have possibly foreseen. Yeah. Cody Baldwin asks, this is a bit of a tongue-in-cheek interpretation of the anti-natalist argument. If suffering is a result of lacking knowledge, all evils are caused by insufficient knowledge, and potential knowledge growth is infinite, then that means there's no way to create consciousness without promising suffering. Is it morally wrong then to have a biological baby? So I have to disagree with the premise of the question, that means there's no way to create consciousness without promising suffering. No, it's not that. Yeah, all suffering is the result of lacking knowledge. All evils are caused by insufficient knowledge. Yes, but that doesn't mean that insufficient knowledge itself necessarily causes evil. There are problems in the world. One problem, okay, caused by insufficient knowledge, is suffering. Well, it labels a vast spectrum of different experiences a person can go through, call them suffering. But there's a whole bunch of problems caused by insufficient knowledge that aren't anything like that, that in fact do the opposite. They provide joy. An unproblematic state is death. Or, that's David Deutsch's way of putting things. All life is problem solving. That's Karl Popper's way of putting things. So when we say that, and when David Deutsch points out this is the principle of optimism, all evils are caused by insufficient knowledge, then one such evil is suffering. And I am of the opinion that suffering is a soluble problem, that all the different instances of suffering can be solved, leaving us with still problems, still insufficient knowledge. That's always going to be the case. But the problems that we will be solving will not involve the solving of suffering, because they will have been solved. Now, we're talking about a distant future here. And of course, there could always be the thing that comes out of the dark cosmos somewhere that could cause us suffering. But everything that we think of now as suffering, all the physical body pains that are unpleasant to us can be done away with. All diseases can be cured. Death of loved ones can be fixed because they don't have to die. Traffic accidents can be avoided. All of these things that cause suffering can be fixed. So suffering itself is a soluble problem. Now, at the moment, it's not. So then the anti-natalists might very well go, and this is the problem, by the way, because of the fact that suffering is soluble, it can't be a basis for morality, because once you've solved suffering, and as I say, I think you can, once you've solved all suffering, you've still got a problem of what to do next. You're still, what should you do? And it won't be about minimizing suffering at that point, because there will be zero suffering. And we shouldn't really be thinking about in terms of maximizing happiness or well-being either, because we've moved so far away from a place where we have to worry about differences in well-being that it's just different species of well-being. So do we maximize off in this direction or that direction? Well, this is why having these bases for morality is wrong, and just regarding morality rather as the solving of moral problems, as science is the solving of scientific problems, is really the way to conceive of things. But at the moment, we have heuristics which are useful, avoid suffering where we can, and increase well-being, and so on. You know, these kinds of things. But given that today, at the moment, we do have this problem of suffering, how do we respond to the anti-natalists? Well, what a poverty-stricken conception of people that is. Firstly, the idea that, that people are just born into this world suffering or potentially suffering. They're also born into this world potentially experiencing a lot of joy. And for every year that goes by, the amount of suffering decreases and the amount of joy increases. And moreover, denying potential parents, the joy, the incomparable joy of having children itself is a cause of suffering, massive suffering for the parents, for the people already alive. So, yeah, I think that people, and this will become increasingly more true, people are sources of joy more than experiences of suffering. So I think that's the way to look at it. Is it morally wrong then to have a biological baby? And I know Cody doesn't really think that, as he says, tongue-in-cheek. No, it's one of the most moral things you can do, is to have a child, to bring a child into the world. So we aren't promising suffering to children at all. We certainly shouldn't be. The world isn't promising them suffering, really. Things can go wrong, and but parents can do a more or less good job and can tend in the direction of minimizing suffering. Now, of course, eventually people grow up, and you know, they make their own mistakes. Indeed, people, you know, youngsters make their own mistakes, and that can cause suffering right now, because now we don't know. But being in a position of ignorance is the position that we are always in anyway, at any time, no matter how far into the distant future we have to go. And maybe the child that's born tomorrow, or is decided on being born at some point in the future, is the one that is instrumental, key, crucial in solving the problem of suffering, which is another reason why we should have more children and counter the anti-natalists, some of the worst pessimists of all, I think. Vish, might be a bit technical, but how are the many theories of QM structured? How are, for example, QFT, it's quantum field theory, QED, quantum electrodynamics, QCD, quantum chromodynamics, the standard model and quantum computation related to each other? Are they all consistent with each other and the many worlds interpretation? Wow, Vish coming in very hot on this one. Okay, so this is a challenge. So I'm, firstly, although I did undergraduate stuff in physics and I did, sort of master's in astrophysics, I may very well butcher this because I'm not a professional physicist. But, I've tried to keep up as a layperson in these areas. So what I would say in response to that kind of question, it's kind of like asking, how are the many different theories of biology structured? How are, for example, zoology, ornithology, botany, and so on, and maybe we would say the theory of evolution and neo-Darwinism and the theory of genetics. How are these things related? Are they consistent with each other? Yes, they have to be consistent with each other because they're all basically different ways of looking at the same thing. Or a better way to put it perhaps is there is a subject area, call it quantum mechanics, I'd rather call it quantum theory, and then there are disciplines within those areas or areas of focus that some physicists focus on more than others. So let's try and tease these out. So quantum theory is the broadest possible umbrella under which these things fall. I'm going to get in trouble off real physicists for saying this, I'm sure. Quantum field theory is where you bring in special relativity. And so special relativity, considering how particles move at close to the speed of light, then things begin to change. And so uniting special relativity and quantum mechanics using a field approach, which is what physicists do. Physicists like waves, physicists like particles, physicists like fields. And so this is a way of bringing these two otherwise disparate branches of physics together, quantum mechanics and special relativity. We don't know how to bring together quantum theory and general relativity. We can't do that. We don't know how to incorporate gravity, but we can incorporate the effects of special relativity. And there's your quantum field theory. And then quantum field theory has within it subgenres as well. Quantum electrodynamics, charged particles. So how charged particles move around. How do electrons move around? How do protons move around in fields at the quantum level? What's going on there? Quantum chromodynamics, bringing in the strong force, I believe, gluons and that kind of thing. How do they behave quantum mechanically? So that's what that is. So quantum electrodynamics and quantum chromodynamics, I believe, are species of quantum field theory. Quantum field theory is a thing to try and help understand how to understand all this stuff, quantum stuff, with relativistic effects. And what goes on there is we regard particles as excitations of a field, and the field is in some sense more fundamental than the particles. I don't like to think about it that way. I just like to think, well, what are particles? Well, excitations of the field, given this theory. We can still regard them as fundamental. There's a fundamental way that the field can be excited. It can be excited in one way and give you an electron, and excited in a different way and give you a photon, let's say. The standard model is specifically that part of quantum mechanics focused on just what the particles themselves are doing. Quantum mechanics is a theory that purports to govern everything in the universe, right? Leaving aside gravity, space-time. But if you just focused on, what's matter made out of? Well, matter's made out of atoms. The atoms consist of protons and neutrons. The protons and neutrons are made out of quarks, up and down quarks. They're in the nucleus, orbited by electrons. Electrons are a species of lepton. There are different kinds of leptons, like muon, I think, is one. All these different. Then you've got bosons which mediate the forces. And so in the case of the electromagnetic force, you've got photons which do that. Then you've got gluons which mediate the strong force. And so you've got all these particles, and they call it the particle zoo. And so that's the standard model. And so it's a subgenre under the umbrella of quantum theory. And then quantum computation. Well, quantum computation, again, it's a subgenre within quantum theory. It just brings in computation. It says, what can a computer do? Given these things are made out of matter, they're made out of physical stuff. So what limits does that impose, or what does it allow, rather? So that's the theory of quantum computation. So Vish's question then goes on to say, how are they related to each other? Just like that, I would say. Umbrella term and then sub-disciplines within the area of quantum mechanics. Are they all consistent with each other? Yes, in the same way that zoology and botany are consistent with biology. And the many worlds interpretation. Yes, they have to be. All of these things, in fact, can only be understood best through the many worlds interpretation, which is just applying realism to understanding the experiments of quantum theory, and moreover, trying to understand what the formalism is telling us. So when we look at something like the Schrödinger wave equation, and it says that all of these different possibilities are the thing that cause this one thing we observe to happen, well, all those different possibilities really exist, because if they're all coming to bear on, what actually does happen, then they all really exist. They're causal, so they're there in reality. So that's all the many worlds interpretation is kind of about. Thanks, Vish. How's it? As I say, really coming in hard with that one. RJ, hey Brett, obsessed with all your content and Deutsches as well. Many media outlets and accredited journals are prophesying for most major coastal cities to be underwater by 2060. Is this the same blind pessimism as peak oil forecasts in the 90s and the Malthusian trap in the 18th century? Yes, absolutely. Any prediction of that kind is, of course, as you say, actually a prophecy. We cannot know what things will be like here on planet Earth in 2060. We don't know. What a prophet of that kind presumes is that given what we understand now of, let's say, climate science, extrapolating to 2060, let's say, and I assume they're using the worst possible estimations for the rate at which the polar ice caps would melt and therefore sea levels would rise. Assuming nothing is done, then yeah, absolutely, maybe the worst could happen. But of course, people are here. We're on planet Earth. If we can cause the problem, we can undo the problem. Problems are soluble. There's nothing inherent in melting polar ice caps, which means that we cannot undo the problem. We know of ways to cool the globe, in theory, in principle. Just put big enough mirrors in the sky and it will shine the stuff back towards the sun. I mean, yeah, sure, expensive, sure, engineering problem, but in principle, we know how to do this. And so, will coastal cities be underwater in 2060? No, I would say most won't be. You could just build walls, couldn't you? I mean, that would be a simple low-tech solution to this. Amsterdam and most of the Netherlands, I believe, would be underwater now if they weren't using technology to keep the place effectively afloat. Because they're extremely smart people, great engineering tradition. They're already doing what every other place could do. They can teach the world how you stop being inundated by the ocean when you live adjacent to it. Okay, so yeah. So I better go. So that's the Patreons. Thank you to my Patreons for asking those questions. Adil, thank you for your contribution. We'll prioritize you next. Hi, Brett. Could you please explain the difference between computational universality and explanatory universality, and why is the distinction pretty important? Yes, so this goes to the distinction between hardware and software. Computational universality is what the typical computer approximately has. We say approximately has because in order to be truly universal, in other words, to run any program that can possibly be written, you would need an infinite amount of memory, because some programs would require an infinite amount of memory. So we can only approximate that. But, we don't need to necessarily simulate stuff, let's say, that requires an infinite amount of memory. We can just approximate it. Okay, so that's that. A computational universality implies the existence of a computer that can do the work of absolutely any other computer that can be built. A single device that can do the work of any other. And so that is, as I say, approximately desktop computers. This is what Turing's great insight was. Church, Turing, Post. I think these guys got there and figured out that not only was there this one computer that could do the work of any other, but also, incorporating the work of David Deutsch, there is a computer that can simulate efficiently any physical process. Any possible physical process can be computed by this particular device. So this is about the hardware, what the hardware can do. You can write programs for this computer, programs for this bit of hardware that can do anything that any other process can simulate any other process out there, from atoms through to galaxies and literally anything in between. And that includes people, of course. Okay, so all you need is the right program to put in. So that's what computational universality is. But then what's explanatory universality? Well, it's a layer on top of that. It's what we have. Now, we know how to write the program that simulates how planets move around the sun. And so we've got good computer simulations of that, and we can predict where, Jupiter's going to be in the year 2060, let's say. And we can write programs to simulate, how an aeroplane flies, hence we have flight simulators. We can write programs that help us to compose music, like GarageBand and so on. But what is the program for a person? Well, it's got to be the thing that can explain anything, because that's what we can do. That's what explanatory universality is. The laws of physics are comprehensible. We know that because of what I just said about computational universality. Because comprehensibility is a kind of computation. We understand stuff. And the laws of physics themselves are computable. Any physical system out there can be captured by a computer program if only you know what that computer program is. And so therefore, effectively what people are virtual reality renderings of their models of the world. Okay, we are minds running on brains, and we're modeling the rest of physical reality out there. You don't have direct access to physical reality. There's this layer of interpretation between your mind, which is doing the thoughts, the evidence that is coming into your senses, and then physical reality. You're interpreting this evidence and creating models. The models are inaccurate. They can always be improved. But you can explain anything because of what a mind is as an explainer. Postulating things that can't be explained is all that one is doing at that point. I know a lot of academics do this. I know a lot of intellectuals do this. A lot of science communicators do this. But what if the laws of physics can't be understood? What if there's a thing out there that can't be understood? Well, you're just saying God. That's really what we're saying. It's supernaturalism. Now, I credit supernaturalism to the work of Lily Tennant, but Lily told me that, in fact, Ayn Rand used supernaturalism as a term. So whatever the case, as soon as you start saying things are incomprehensible to people, you're postulating the existence of a thing that is beyond nature, that sits outside of the laws of physics as we know them. Now, of course, you can always say, what if the laws of physics do turn out different? What if we overturn computational universality? Then all bets are off, sure. But I would like to think, for example, that whatever the quantum gravity theory of computation is, we'll just see quantum computation as it is now as a special case. So we'll still have this universality. It could rule out explanatory universality, but thinking about that now, all that's doing is just putting a wall in front of progress. Better to just presume computational universality holds, because if you don't, it's just postulating God. There's an entity out there, or there's a thing out there beyond the comprehension of people. Okay, fine. But it doesn't get you any further than that. It doesn't get you far. Whereas assuming the opposite, assuming everything can be understood, does allow for progress. In fact, it's the precondition for progress. Okay, so thanks, Adil. Great question. Now I'm going to go to all the very many Twitter questions that I got, and or at least try and get through some. Let's see. Beginning with David Hearn. David says, is the number of Harry Potter universes finite or Aleph null? Okay. Harry Potter universes, firstly. Harry Potter universes is a term that arose in discussions about the fabric of reality like 2 decades ago or something like that. We were talking about what the structure of the multiverse implied. And one suggestion was that, well, in the multiverse, there must be universes in which there's just series of coincidences happening. And these series of coincidences can make things like magic appear to work, never actually work, or appear to have worked. An example is There is a universe out there where every time a bespectacled boy holds aloft a wooden stick and says abracadabra, electrical sparks come flying out of the stick. What do we make of that? We do not say that the bespectacled boy holding the stick aloft and saying abracadabra is the cause of the sparks coming out of the stick. It's just that by coincidence, extremely rare coincidence, sparks came out of the stick and continue to come out of the stick every time he says it. And the number of times this happens in the multiverse increasingly diminishes to a vanishingly small number. In fact, it begins as a vanishingly small number and it just keeps getting smaller and smaller and smaller, asymptotically approaching zero. The number of times that sort of thing happens in the multiverse. And this is what we call a Harry Potter universe. Technically, such universes exist. They're not much worth worrying about because they, as we say, that the structure of the universe is determined by information flow, and it's only where knowledge is being generated, genuine knowledge, that things are replicated. And in such universes, you're not generating knowledge. There's no such thing as real magic. And so in those universes, every time Harry Potter, every time this bespectacled boy holds aloft the wand and sparks come out, the next time he holds it aloft, it should behave exactly like it does in our universe and does, except, again, in a very, very tiny, tiny sliver of universe, a tiny proportion of universes where, again, the sparks come out and repeat the process. Okay, so that's what a Harry Potter universe is. It sounds bizarre and strange, but yeah. As David Deutsch says, I think in The Beginning of Infinity, somewhere in the multiverse, all fiction is fact. So long as it doesn't violate the laws of physics. As long as it doesn't violate the laws of physics. But again, that's just due to, well, in many cases, it can be due to coincidence. So yeah, okay. So that's what Harry Potter universes are. Are they finite or Aleph null? Oh, I think neither. Aleph null is this term used to label, I think, countable infinities. But universes can't be ordered. They're not countable. They're uncountable. There's nowhere to start counting them. In the same way, there's nowhere to start counting the real numbers. You can count integers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But real numbers, the real number plane, so the set of all decimals, there's nowhere to start. Where do you start? 0.1? Well, no, you can go smaller than that. 0.01, 0.001. So, yeah, the real numbers, the decimals, the fractions, there's no smallest one, so you can't count them. So that's not, even though it's an infinity, it's not Aleph null. Aleph null or Aleph naught is the size of infinity that the integers occupy. But the real numbers is bigger than that. Is it 2 to the Aleph null or something like that? I'm not great on number theory. So whatever it is, it's bigger than Aleph null. And I think that in the case of Harry Potter universe, it's bigger for the same reason that any subset of universes is going to be uncannibly infinite, because our best theory suggests that the number of universes that existed at the beginning of time, at the Big Bang, is the same as now. It's just that they have differentiated over time. There's always been this number of uncountably infinitely many universes. It's just that they all used to be absolutely perfectly identical, fungible at the beginning of the universe, and then began to differentiate over time and continue to differentiate over time. But for any slice of the multiverse, any universe, any object within the multiverse, there are uncountably infinitely many versions of it, many of which will be absolutely the same. And then you get variation as the universes differentiate. So that gets technical. I like Alfredo's little response to that. Aleph null bottles of beer on the wall. Aleph null bottles of beer on the wall. Take one down and pass it around. Aleph null bottles of beer on the wall. Yes, sir. You remove one from infinity and you've still got infinity left. It's one of these weird things about infinity. It's like, are there more even numbers or are there more multiples of a billion? Well, most people would say, well, there's got to be more even numbers than there are multiples of a billion, but that's not true, even for the integers, because for any even number, you can be given you can put in one-to-one correspondence with a multiple of a billion. So 2, a billion, 4, 2 billion, and so on. But for any even number you can think of, I can think of a multiple of a billion. So there are the same number of multiples of a billion as there are, same number of multiples of a billion as there are multiples of 1,000. It's strange because there's infinite in both cases. Aleph null, in fact, in both cases. Christian Dean asks, a conclusion I've come to after accepting Deutsch's principle of optimism is that I must cryogenically freeze my body at death because the problem of how to bring a frozen body back to life must be soluble. There are no alternatives. Am I wrong? Michael Golding said no. I don't know. I don't know because I don't know. Well, there's a whole bunch of questions to ask here. What does I mean in that case? If you cryogenically freeze a body and a brain, and what some neuroscience says at the moment, that our way of doing this at the moment causes the water inside the cells to burst through the walls of the cell, destroying the cells, so that, you know, this would be a kind of information loss that the laws of thermodynamics would have something to say about. And if that's the case, then this is a problem that can't be solved because there's a law of physics getting in the way. The law of physics possibly being one of the laws of thermodynamics saying, well, you know, the information that was in the brain now maybe is lost, but maybe a version of you can come back. Possibly not the same. Possibly you've lost a whole bunch of memories. Possibly you've lost some of your personality. So I don't know. I don't think anyone knows enough about this thing that happens at death to people. What happens? I don't know. It would be better if we could somehow or other map to high fidelity all the connections in the neurons and store that in a computer somehow. I think that would be a preferable way of doing things before, you know, instead of cryogenically freezing. You know, after all, whatever's going on in the brain is substrate independent, right? So what we're interested in is preserving the mind, so much the physical brain. So if we could preserve the mind by copying the brain in some way to very high fidelity, you don't need to go about freezing things. You've got it on a disk somewhere that is far more robust. But yeah, so I don't know. But hey, as I say, I don't know. So if you're in a position where you can cryogenically freeze yourself and you can't avoid death, okay, that'll be my first plan. Avoid death in the first place, so you don't have to worry about cryogenically freezing yourself. But if you are in a position to cryogenically freeze yourself at death, yeah, why not? Why not take? Yeah, absolutely, yeah. If you've got the money, like I think Walt Disney or whoever, absolutely, yeah. I don't, as I say, I don't know, and so therefore, in that situation, take a bet, take a punt, and yeah, freeze yourself. Josh is next. How should we think about the moral, institutional, and political questions of when to act on a new theory if stakes are high? How to find the right level of testing, criticism, and corroboration before trying something that could cause or prevent huge misery, existential risk. It goes on to say, Bayesian epistemology and precautionary principle both purport to offer answers which may partly explain their success. How can we find better answers? Okay. How should we think about the moral, political questions of when to act on a new theory if stakes are high? How to find the right level of testing, criticism, and corroboration? That way of framing things is justificationist. It's saying that you've got this theory, but only if you've achieved a certain amount of testing or criticism or corroboration are you then kind of justified in using the theory. But this is the wrong way to think about things. If you have a problem, then presumably the theory is there as a solution to your problem. And the theory will be an explanation that will be good or it won't be good. So the question is not when to act on a theory. It's if you have a problem, do you have a solution? In which case, implement the solution. And if you don't have a solution, continue to be creative to come up with one. Before trying something that could cause or prevent huge misery, well, yeah, we'd need a specific example, okay? it sounds like, yes, this is the intellectuals' concern. AI, the AI apocalypse is coming. Should we, how should we think about AI given moral, institutional, political question, when to act on a theory of AI, let's say? That's kind of what might be hinting at here. But AI solves a problem. Now, yeah, so I have talked about this in fact, the last live stream and various other places. At the risk of boring listeners, I tend not to think in terms of so much the risks of any given solution, the risks of any given piece of technology, but rather the rate of progress is more important. I call the master problem the slowing of progress. So anyone who holds up a particular piece of technology or a particular solution and says of that thing, this thing's going to be the end of us, therefore we've got to slow down knowledge creation into this thing because it's going to be the black ball, as Bostrom would call it, that's going to wipe out humanity. Anytime someone does that, what they're saying is slow down progress. Slow down, people. We're creating knowledge too fast. We're solving problems at a rapid rate. I can't keep up, something like that. But I would say no. Of course, we don't want people to use technology in bad ways, but we need the technology first in order to solve problems. That knowledge is, as people have said before, power, and power can be used for good or evil. I am very reluctant to hand over decision-making about the use of any technology to moral moral institutions, let's say, like churches, political institutions like governments, because they're just made of people. And so I think there needs to be a diversity of approaches. And if someone doesn't want a particular technology like AI, well, then they can have an island that rules out AI, let's say. But for the rest of us who think that AI is bringing many, many benefits, does it come with hazards? Sure. So does the ubiquitous spreading of food around the world. So does the internet. So does, name your thing, cars come with car accidents. Of course, we're told by intellectuals that AI is a special case. Haven't we been told that in the past about everything? It's that pessimist's archive on Twitter that, comes up with old news stories saying about how, name your technology of the past. And there was an intellectual saying, this is going to be the end of civilization. And so we're at the point now where AI is the thing that's going to be the end of civilization. So, yeah, we don't need to go and have a particular level of testing, criticism, and corroboration. Instead, we need to think in terms of problems and their solutions. What problem is being solved? Is it a good solution? What problems are being created? Okay, yeah. Bart has asked, what's the difference between reason and rationality? I don't think there's a strict accepted definition, distinction to be made. The way I tend to use the words is reason is just an umbrella term for absolutely every subject that aims at trying to understand reality. So science is a special case of reason. It has special tools within it that allow us to understand the physical world. But history is a case of reason as well, where we're using special tools to try and understand what happened in the past. Morality is a form of reason, a way in which we can use reason, but also it is part of reason at its best. And, things that aren't moral are not using reason, unreasonable, let's say. Rationality is that word I would use to describe error correcting. And so it is a tool of reason. It's one of the tools of reason. So that's the word. Now, other people may have different ones. You could obviously use them as synonyms in a sense. You could say someone is reasonable, someone is rational, similar kind of senses. But yeah, rationality seems to me to be more focused on, if someone's being rational, they're focused on correcting errors, identifying correcting errors. And so, but a person who's being anti-rational or irrational, let's say, is not focused on correcting errors. isn't concerned about the errors. Anti-rational is actively entrenching errors in some way. So it's about errors. That's why rationality is about errors. And reason is broader than that. The generation perhaps of good explanations might be what reason is more about. So it includes things like creativity and so on. John Mandelbauer has asked, why is there anything we measure that confirms that angular momentum is not conserved, but we choose to believe it is conserved and not just measure anything? I don't understand that question, I'm afraid, John. Confirms that angular momentum is not conserved. Angular momentum is conserved. So I don't understand that. I may have to ask John or follow his link, which I'm not going to do now, unfortunately. Pathseeker has asked, what should one study after quantum mechanics? I don't think there's an answer to that question either. There's certainly not a universal answer to that question. One might study quantum mechanics and find out it was terribly boring. In which case the answer is, who knows what your interests are? So the answer could be poetry or gymnastics. But I guess if you're asking, you're a physicist and you've studied quantum mechanics, what should you do next? Well, again, that would be up to you. I don't know. But if you're, there's not much point giving you a study schedule, because by the time anyone finishes completing quantum mechanics, they will know way more than any possible advisor of theirs would know about what they want to do next. If you're asking today in 2022, should I study quantum mechanics? And I say, well, are you interested in it? And you say, yes. I said, well, okay, yes. What should I do after that? Well, you'll know after 6 months. After 2 weeks of studying quantum mechanics, you might know that you don't like it, or you do like it, but you really only like this stuff. Like we were talking about before, the different genres, I suppose, of quantum mechanics. Maybe you're more interested in the philosophical stuff. Maybe you're more interested in quantum computation. It's a broad field. Maybe you're interested in the experimental stuff more than the theoretical stuff. So again, not a universal answer to that. What do we say? Problems are parochial. And so if you have a particular interest in something like quantum mechanics, that's because you have a problem of how to stimulate your curiosity, and quantum mechanics seems to be scratching that itch for you. But that's your problem, not my problem. And so therefore I can't advise you what you should study after, because you will have a different problem. You'll be in a different problem situation. Denisovich has asked, historically, dynamic societies have emerged when there was a tradition of criticism. But what exactly allows for such a tradition of criticism to emerge in the first place? So dynamic societies are those ones that are where a tradition of criticism dominates, yes. What allows for the tradition of criticism to emerge in the first place? I don't think we know. We don't have a good history of optimism. One guess would be a simple rejection of dogma and authority. Okay, we begin there. It might not be a general tradition of criticism, but it might be a rejection of things like dogma. People beginning to say, these ancient texts don't have all the answers. Can we not just adhere to what the text says? The holy book doesn't have all the answers. And that could begin, that might not bring on a wave of an entire tradition of criticism, but it could get the ball rolling, so to speak. Rejecting authorities as they're understood, maybe rejecting the kings, implementing a way of replacing leaders, democracy, okay? Like the ancient Greeks had a version of democracy, of replacing the rulers over time. And eventually, I guess, enough of these little stones fall, and then you have the avalanche of a tradition of criticism, where then everything is opened up for criticism, for improvement, for progress. And then you have the panopticon way of dealing with problems, that you don't just consult authorities and dogmas. Instead, you rely on individuals to deal with their problems and experts to be advisors, But we have 2 steps forward, 1 step back sometimes. Recently, maybe the experts have become an expert class, and instead of them providing us with kind wisdom and advice couched in fallibilist terms, maybe they're coming to us more as authorities again, which is not good. So we have to guard against that. Any threat to a tradition of criticism where some people are, and some people's words are held immune from criticism because they're experts, let's say. You can't defy expert advice, let's say, would be antithetical to a tradition of criticism. But what allows for it to emerge in the first place? I don't know, and the history would have to be written of this, but I guess it has to start somewhere, with someone questioning something and others agreeing, and it could be things like, questioning received wisdom, doctrines, dogmas, and the authorities in a society. $$ asks, what does it exactly mean for a guest to survive criticism error correction? Because, for example, Newton's theory of gravity has been falsified, but it's still knowledge. In other words, when can a theory be considered to have survived criticism? Yeah, so knowledge doesn't mean you have to have survived criticism. You might very well have been refuted, but it still counts as knowledge. Why? Because one way of explaining what knowledge is, not the only way, but one way is it's information that solves a problem. Okay, so knowledge is information that solves a problem. It might be false. The explanation might be false. It's no longer a good explanation, but it solves the problem for what you're interested in. You want to get your rocket to the moon, you can use Newton's theory of gravity, though it's been falsified, technically falsified. It allows you to make sufficiently good predictions to do the job. It solves the problem you're interested in. It still counts as knowledge. When can a theory be considered to have survived criticism? Well, just in those cases where it's not refuted by criticism, by the charge that it's a bad explanation, or by experimental refutation. And so, yeah, what does it mean exactly? I can't. It's one of those things where I guess Wittgenstein would say, my spade is turned. In other words, I don't know how to further break down what does it mean for something to survive criticism. It just means that all creative attempts by people to shoot this thing down have failed. That doesn't mean it will continue to be in that position of being unable to be criticized. In fact, we should expect all of our knowledge to eventually be successfully criticized in some way, shape, or form, and thereby improved. Tadas asks, what do you think makes a good meme resonate with other humans and spread across widely? So I don't think a meme to spread needs necessarily to resonate with other humans. And the reason for that is because many memes are inexplicit. That's one thing. We can't actually articulate out loud what they are. And also are not good for us. So they're not resonating for us as such. Whatever resonate sounds like it's got this. Oh, hold on. Tadas has said, what do you think makes a good meme resonate with other humans? Okay, apologies. So a bad meme is, of course, something anti-rational, but Tadas hasn't asked that. He's asked what makes a good meme resonate with other humans. When it just comes back to knowledge. A meme is a kind of idea that gets replicated because people are able to copy the behavior of others, and whether that's their words or whatever it happens to be. The meme propagates by being copied into the minds of other people. Why would a good meme resonate? When it solves problems for people. Memes, ideas, knowledge, okay, a lot of understanding this stuff, it all comes under that same umbrella. I think I've used the word umbrella 3 times now. So yeah, if the meme is useful, if it solves a problem, then it's going to resonate with other humans. And solving the problem doesn't have to be like, well, solving some engineering problem or something like that. It can be solving the problem of what's fun, what makes you laugh. Okay. I feel like having a laugh, that jokes will get spread, and the literal internet memes will spread because they're solving the problem of entertaining people who are otherwise bored. So yeah, when it solves a problem, I would say is the main thing. Likesh is next. He asks, not sure if I can frame this idea into a proper question, but I was wondering, according to our current knowledge, our timeline goes like, there was a big bang, galaxies, solar system, stars, and planets formed, conditions permitted, so life arose on Earth, and finally evolution, basically through trial and error, made us who we are. So based on this, I think we could say that we are here by chance and because conditions permitted and not by design. Now let's assume that there exists a multiverse. So if I'm not wrong, that could mean that there exists a very large number, possibly close to infinity, of Earths like ours, but with slight variations in each one. So finally, my question was, doesn't this sound more plausible if, say, we're actually in a simulation grand experiment of some sort, in which the underlying code basically instructs to form X number of variations of the universe with slight variations in each one? If we assume that a multiverse exists, doesn't it basically imply that all of it is by design and not by chance? That's just a question floating around in my mind. I understand the logic behind my question could be flawed. So what I would say is all that says is the multiverse is true, quantum theory and everything we understand is true, but onto that, we're going to add this assumption that it all exists inside of a computer, rather than just going with realism. Okay, realism is the claim that, well, science is giving us the correct knowledge, some true knowledge about reality, approximately true knowledge about reality. But if it's all a simulation, then the process of knowledge creation isn't giving us true knowledge about reality, but rather what's going on inside the simulation. Reality is outside of the simulation. Now, if you listen to my last podcast about the fabric of reality, or indeed you read, I think it's chapter 6, Universality and the Limits of Computation from the Fabric of Reality, David explains there that if you were in a simulation, then unless the simulation was able to simulate to the level of fidelity reality, then the people inside the simulation would eventually find out that strings were being pulled in some way, shape, or form, that there was an external reality. They'd be able to do experiments in order to find out that that at least something was outside of the universe, because that's what people do. Okay, we're universal explainers. We're going to encounter a problem for which the only way of solving it requires us to refer to a reality outside of the reality we inhabit. So this is a kind of a refutation of that solipsistic view, which related to solipsism, right? So I'm not going to go with you to where it says, doesn't that basically imply it is all by design? No, not at all. I mean, you're just adding on that your feeling is, you said it sounds more plausible if we're actually in a simulation. It doesn't sound more plausible to me at all. Doesn't at all. It sounds more plausible to me that we're not in a simulation, because the simulation, just like we're dreaming it all, is just an assumption on top of realism is true. Reality exists. It consists of everything that actually does exist. Science is giving us some knowledge about that reality. We're not in a simulation. But if you're going to push the argument that we are in a simulation, you're basically saying you agree with realism that science works as it normally would, but we're just going to add on the extra assumption, the extra axiom that it's all in a simulation. And, Occam's razor, I suppose, if we want to refer to that, all else being equal, just eliminate the unnecessary assumptions. It doesn't add anything. It actually detracts from what we know of reality. Yeah. So I think that in Denisovich again. What do you think of the claims that people are born with certain traits, such as being compassionate, hardworking, and creative? Okay. Or that some people are born capable of excelling at algebra or speaking French. Are these good explanations or simply bad explanations? there's a sense in which I can answer yes and no to this, okay? People are born with the capacity to do anything, and that includes being compassionate, hardworking, and creative. Do we have inborn ideas? Yes, I think we do. What those are, I don't think we have much of a clue about. But yeah, we must be born with some ideas. We're not born as blank slates, but those ideas that we're born with are themselves changeable. This is the third way I keep speaking about. There's this great debate that goes on. Are we born with blank slates, or are we born with ideas and therefore are our ideas genetically determined in some way and they just determine our behavior? Well, these are not the only two options we have. We could be born with ideas that can be changed. By what? By us, people who are universal explainers. And a universal explainer can be compassionate, hardworking, and creative. Certainly creative. I think everyone's born being creative. I was listening to Joe Rogan interview Mark Andreessen today, his latest podcast, and Joe was, pushing back against Mark. Mark was saying everyone's creative, very optimistic, saying very optimistic things. In his experience, people are creative. And in my experience too. But Joe said, no, I can introduce you to some people who aren't. Well, that's incorrect. Okay. What counts as creativity? It's a low bar, right? A lot of people aren't using their creativity for composing music and theories of cosmology and poetry and all that sort of stuff. So, to some observers, they would say that person isn't creative. I think that's just wrong. People can be creative raising a family. People can be creative, laying tar on the road. People can be creative in any area of life, human life. Even there's no, like David Deutsch says in the beginning of Infinity, there's this idea that, invention is, 1% inspiration and 99% perspiration. But even the perspiration phases for a human being are creative. People can think of new and better ways to automate or make easier those perspiration phases. We're not like artificial intelligence. We're not like robots. We are able to be creative at every step of any process and any time we problem solve and so on and so forth. So yeah, people are definitely born creative, but they can use that creativity to be compassionate or not be compassionate, be hardworking or not hardworking. Whether they're born compassionate or not is another thing. This Hobbesian view that perhaps people are born just bad and it's very hard to teach them not to be bad. They're born not compassionate and it's hard to teach them to be compassionate. I disagree with that. But that's a whole other discussion. Some people are born capable of excelling at algebra or speaking French. Everyone's born capable of excelling at algebra or speaking French. Everyone. It's just that I would say very early on in our life, we have experiences. When I say very early on, I mean perhaps just before birth, perhaps just after birth, that can shape what we're interested in. Some of us are drawn more towards colors because we're shown bright colors. Some of us are drawn more towards feeling solid versus liquid, investigating the world in different ways very early on, which can shape what, as adults, we go on to be interested in. Some might be very, very interested in, mummy and daddy writing stuff. That text stuff looks interesting. Of course, they're not thinking that in words. Some might be interested in looking outside at the sky. Yeah, these things very early on, perhaps weeks, can definitely, I would say, shape the mind of a person, and therefore cause them to either go down the road of excelling at, let's say, languages, or excelling at mathematics, or excelling at building stuff, or excelling at who knows whatever the thing is. Yeah, but I would not say that people are born inherently incapable of anything. And even if you do have these experiences early on that shape what you do, look at that mathematician who won the Fields Medal, the story that went around about he felt he didn't like mathematics. He became a poet for a while. It wasn't until late in undergraduate or something like that at university he realized he did like doing mathematics and became one of the greatest mathematicians of all time. Was he born incapable of doing mathematics? Clearly not. But many, many people would look at his story, perhaps the first, 15 years of his life, And if they had have met him at 15, they would have said, you've got no hope of being a mathematician. Stick to your poetry, because he didn't show any interest in mathematics. So therefore, he probably didn't do particularly, who knows? I don't know exactly how well he did in tests. But I know there are situations like that. Brian Cox talks about, the science communicator physicist, particle physicist, who says that he got a D on his, was it A levels in mathematics? And I think, the grades are A, B, C, D. E is a fail or something. So he just passed. Proof positive, you can be a great physicist, science communicator, mathematically very, very literate, competent, lecturing people in undergraduate physics, and yet barely pass your year 12 mathematics exam. Great example. Wonderful example. There are many such examples of this. Faraday apparently couldn't do maths very well. So all that says is that people can pick up certain things later on in life. And if you think you are incapable of maths or incapable of languages or incapable of something, there's just a block there. It's not that genetically you're not wired for it. It's that you don't care enough. You're not interested enough. But if you had the problem that required the interest, then you would. You would. Clearly, Brian Cox didn't have the problem at the time when he left year 12 at school of needing to do maths really well. But later on, he figured out, hey, I like this physics stuff. Now I've got a problem because this physics stuff is written in the language of mathematics. I better learn mathematics to a more competent level. And then he probably found that he actually enjoyed it. I know that was my experience. I've had that experience many times. So there's certain courses forced to do at university for the sake of getting the degree in physics and not liking, and then choosing other areas of mathematics and finding out, hey, I actually like this area of mathematics. This is fun to do, specifically the stuff on like logic and computation. I love doing that sort of stuff. It was really interesting. I wanted to understand things like Gödel's incompleteness theorem. I wanted to understand how to program a Turing machine. So that then made maths really interesting to me. A lot of the other stuff, not so much. Okay. Partial differential equations, take it or leave it. A lot of the stuff in classical mechanics, Newtonian mechanics, the heavy mathematics that you're required to learn in order to do some of these really complicated stuff in Newtonian mechanics, really complicated stuff, gives people nightmares. So it's really hard. And surprisingly, you can go into quantum computation and the mathematics is not hard. And yet in Newtonian mechanics, it can be hard. It just depends on what you're interested in. Yeah, okay. So I don't think people are born with certain traits. Alex Gierev has asked, if creativity consists of variation of existing ideas, what is your opinion on using spaced repetition software to enhance creativity by preventing forgetting and thereby accumulating a larger pool of ideas which can be adapted as solutions to new problems? No doubt it works for some people, something like that. Enhancing creativity. I mean, there's been so much work done on this, and I don't think there's a universal answer. Some people work really fast. Some people work really slow. Some people work all day. Some people work in short bursts. Naval has that thing of saying work like a lion, not like a, I don't know, what's the other thing? the thing that sort of works all day. A lion, sleeps under the shade most of the day and then does the thing that it wants to do, goes and chases the antelope. Work like that, especially as a creative person. Perhaps. I know I tend to find that I like that method. But there are other people who are very creative who are obviously following a much more rigorous schedule, and that works for them. So I don't think that, but if something works for you and you feel like, I can feel like this, the creativity is just not coming that particular day for whatever reason. And yeah, doing something different absolutely can help. Absolutely is the thing to do, rather than just focusing on trying to allow the creativity to come. Sometimes it doesn't. And so, yeah, just changing your mind and changing your place, any number of these things can certainly help. So spaced repetition software, yeah, okay, try that, sure. Hamza has asked, can you elaborate on Deutsch's view on IQ? I understand that correlations exist everywhere, but IQ seems to be a strong indicator of success. Some communities seem to produce more stellar thinkers within STEM. What is the explanation for this? Surely it cannot just be interest. Can you elaborate on Deutsch's view of IQ? No, I don't. I can't. I don't speak for David, so I don't know what his view of IQ is. So I'll give you what my view is. I understand that correlations exist everywhere, but IQ is a strong indicator of success. Yes, I agree with the people who say people who score high on IQ tests tend to be successful in society. There's no argument with that. The argument is IQ tests measures of intelligence or measures of creativity? These are different things. Even if the IQ tests the results are consistent over time and are predictive of success in society, you fit into society, great. You can climb the corporate ladder, great. You can be an engineer, great. All of that just means there's a certain kind of knowledge that IQ tests are measuring, how well a person fits into society. Now, if you want to call that kind of knowledge intelligence, fine. But then there's something deeper about people. Call it universal explaining, call it creativity, which is much deeper. Now, I happen to think that, if we're going to properly use the word intelligence, then what we mean is creativity. And I don't think there are differences between people. There's differences between people, as Popper said, in the little bits of knowledge they have. But we are all infinitely ignorant. Famous stories of mathematicians and physicists who did brilliant work, but unfortunately also lived up to the stereotype of being a little bit crazy. Gödel is one. So why? Because although these people have great amounts of knowledge and proficiency in certain areas and can even think quickly in certain areas, they can be deficient, heavily deficient in other areas. Does that mean they're not intelligent, or they are intelligent? Does Gödel's mathematics make him intelligent, but his constant paranoia make him unintelligent? I don't think it's the right question. I think that intelligence should just be a qualitative measure of whether or not a system is capable of creating new explanations. If that's the definition of intelligence, and it should be for something like SETI, the search for extraterrestrial intelligence, what we're really searching for there is people. We're searching for entities that are universal explainers, like us. I think that's a good definition of intelligence, in which case there's not a sliding grayscale. It's black or white. Either they can do it or they can't do it. Other animals on planet Earth can't generate explanations. They can't be creative in the way that we can. We people are unique on the face of this planet. We can all create explanations. And I'm not just talking about the successor of the unification of quantum theory and general relativity. That's not what explanations are only. They also include explanations about what do you think is the best thing for you to cook for dinner tonight? You have an explanation for that. What is the explanation for how you get to work each day? There's an explanation for that. You're generating explanations constantly. You can turn this creative capacity of yours onto anything. That's what intelligence is. There's not a gray scale of it. Either you can do it or you can't. Now, can some people come up with better explanations than others? It depends upon the particular area they're interested in. But as a general measure, you either are able to do that thing or you can't do that thing. So I don't buy into IQ for that reason. Okay, I think it's a silly way of talking about people, reducing people to a number. I think it's immoral, besides everything else, aside from useless. I think if you've got a job and you're offering it to people, either the candidate is a good, friendly, reliable, gregarious person, willing to learn, perhaps has some background knowledge that you require, or they don't. This whole idea that IQ tests are in some way useful in trying to assess employees, ridiculous. You're never going to have two people who are exactly equal and you're going to have to split them based on IQ. Another way of looking at IQ is this person is scoring high on the IQ test because they've practiced lots of IQ style questions. And maybe the IQ test also measures for conformity, but maybe you don't want conformity. Maybe you want someone who thinks outside the box and so can second guess the IQ test and thinks beyond what the IQ test the creators of the test thought. These tests are made up by psychologists, among others. Can you think like a psychologist? What you think the best answer is? So, yeah, I don't. You can rank order people based on maths tests, on history tests, on IQ tests. Name whatever the test happens to be, and you will get a rank order of people. But it doesn't really point to anything truly deep about a person. It points to a specific kind of knowledge that they have. That's all. Mathematics tests point to mathematical knowledge. IQ tests point to supposedly a broad range of knowledge and might be predictive of certain things. Lots of things are predictive. It's also predictive if you're brought up in a certain kind of household as well. But are you going to employ someone on the basis of that? Okay. So Aniket has asked, read any good fiction lately? I'm getting to the age now where I used to read a lot of fiction. I'm getting to the age now where, I don't know, I'm more nostalgic, and I reread things more often than I read new things when it comes to fiction, when I need time off from reading all the other non-fiction stuff that I'm doing. So I read Lord of the Rings now and again, sort of every couple of years. I reread that. Christopher Lee, who played Saruman in The Lord of the Rings, said he would read Lord of the Rings once a year. Because I find I'm transported to the world. Talk about running virtual reality renderings of places. That Tolkien, with language, is able to do that. Has been able to do that. And so I love reading Tolkien's works. A drizzly grey day with Lord of the Rings, sitting by a heater, looking out the window. Fantastic. But I read Star Wars Extended Universe stuff. The Godfather series is fantastic. Hannibal, the Silence of the Lambs book. I've reread those recently, and in terms of new fiction, nothing new recently. I'm not a huge science fiction fan. I do read some, as I say, Star Wars Extended Universe, but the thing I like about Star Wars is it is very much within the fantasy genre. They don't care about the laws of physics. Even with hard science fiction, I always find difficulty with when they start breaking the laws of physics. Sometimes they don't, but when they do, I just think, how does this really work? Okay, yeah, but there's, as David points out in one of the books, there is objectively better and worse science fiction and fiction generally. You can call yourself science fiction, but you're not. Star Wars is the perfect example. In fact, I would say Star Trek is fantasy, not science fiction. Because saying that the way in which you travel beyond the speed of light requires gravity dampers, but you never actually explain how the gravity dampers work. Well, it's fantasy. You're in a world of fantasy. You're not in a world of science fiction as such. Because science fiction, I would say, is, well, here are the laws specifically. There are some people that do that. I think Greg Egan does that. Adil has asked, Brett, do mentally gifted challenged children owe their proclivities to differences in hardware, processing speed, memory, input, output, or to differences in software? Different interests and why? Well, firstly, I don't know, would be the first answer. There would have to be differences between people in terms of the hardware, yes. I think that the hardware can be changed. This whole thing of neuroplasticity is, I think, speaking to the fact that we can change our hardware. We can change our hardware in some way. We can change the speed and we can change the memory. People can be taught how to be brilliant with their memory. You see these YouTube things of people being able to recite, pi to a certain number of 1,000 decimal places or something or other, or just have really good memory, be given a list of 60 items, random items, and then be able to recite them back immediately. And I've seen, people talk about how they used to have a terrible memory and then they use these techniques and they became good at memory. So you can train your memory. Now, memory is hardware. So there must be a way of growing that part of the brain just by repetition. And so the hardware can respond to what the software is doing. This is why a human being is so unusual and strange in terms of they definitely obey the laws of physics and so therefore conform to computational universality. But that's not to say we're like any other computer in existence. We're not. Any other computer can't make choices, can't be creative, doesn't have free will, whatever, however you want to put that, isn't conscious, as far as we know. But it might very well be the case, I don't know, I'm not a neuroscientist, but I don't think any neuroscientist knows this yet, that we can actively grow parts of the brain, obviously unconsciously. Differences in hardware, memory, software. Yeah, I think that could explain some. I think that the people who are labeled as challenged, let's say, may have very short memories. That could potentially be developed, but maybe aren't over time for whatever reason. Maybe their clock speed or effective clock speed of regions of the brain is slower. Maybe that could be changed over time as well. Maybe not. So maybe some people are limited in that way. Not to say limited in explanatory universality. They still, in principle, could understand anything that's understandable, but likely won't show interest in it because they'll get bored very easily. And so boredom and interest might very well have, there might be something to do also with, how fast the neurons are firing, which is a matter of hardware. But in principle, they could, pay attention for long enough and understand the thing. So I don't know. But I think that when it comes to gifted people, certainly, I think that early on, they gain crucial knowledge. And they gain crucial knowledge, therefore background knowledge, especially in things like mathematics. They understand things at a very young age, perhaps as toddlers, that many of us don't understand until we're teens or later. And so therefore, they've got this massive head start. Now, it's precisely what those things are we don't know, because so much knowledge is inexplicit. And because it's inexplicit, that means it's very, very difficult to teach by virtue of the fact that you can't tell someone how to do the thing. It's inexplicit. And so, but children are faster learners, not because their brains are faster, this is a related topic, but rather because they're unencumbered by anti-rational memes. This is my idea anyway. Well, I don't know if it originates with me, but this is what when people ask me about, but children learn so much faster. They learn language faster and so on. They can learn anything faster. They show interest and curiosity and everything. Why can't we keep that up as adults? Because we learn things that actively cause us to slow down our learning. What great irony. And unfortunate that we pick up this baggage along the way from schooling, teaching, from other adults in life, perhaps even just other kids that we grow up with as well. We're made to feel bad about learning over time, and so we become worse learners over time. We gain anti-rational memes. Anti-rational memes are these things that withhold themselves, cause us to withhold things from criticism. As a kid, we don't care. We've got, in some sense, no shame, no fear, no embarrassment, or very minimum amounts of that. And as we get older, we do have fear. We get shame and embarrassment. And so we're less likely to try as hard and persistently for as long, for fear that we're going to appear stupid. Let's say, is one example. I have this, I often talk about my inability to learn languages. And I know it's a software issue. I know precisely what the issue is. I get embarrassed in trying, and then I get bored because I can't make the sounds that need to be made. And I try and I get it wrong. And the more I try, the sillier I sound. I just think I'd give up. Tired of making myself sound stupid. And that's I know what the problem is. And I know I could just try harder and all that sort of stuff. But I think this is the kind of thing. This is the kind of thing that slows people down from learning. Okay. Learning what bores you. Children don't know what bores them yet. They haven't figured it out yet. Everything's exciting. But eventually, they're just by virtue of the fact that there's only so many hours in the day, you rule certain things out. They're really interested in this thing, less interested in this thing. And the thing that is slightly less interesting becomes increasingly less interesting over time as other people tend to develop those skills and you don't. You tend to preserve the interest in the thing that you are best at and excel at, and perhaps is more rare in your social circle, let's say. among other things. Okay, so I'm just going to scroll back up through the chat here because I've not paid attention apart from to Adil's questions. John Julius Jamora asked about an hour ago now, more than an hour. Complete noob here. I just want to use math effectively on day-to-day scenarios. Where do I start? Any book recommendations? No. Although I taught maths for a long time, no, I think there are much better people to ask than myself for that. It depends on what area of math. Maths is such a broad area, like you're just talking being able to do mental arithmetic. There's that Arthur Benjamin guy. Arthur Benjamin, the mathematician, he calls himself. Look him up on YouTube. He's done TED Talks. Fantastic, amazing. He's got a course out there for how to do mental arithmetic better. He'd be a much better person to consult about something like that. Just pick up his course. But otherwise, math on a day-to-day scenarios. Again, what is your day-to-day scenario? Are you working in home loans, let's say? In which case, how to figure out percentages and decimals and stuff. So I don't think there's a simple answer to that. Any book recommendations? For all the terribleness of the school system, the textbooks are usually quite good, right? So if you are an adult who feels like you want to know maths, I'd pick up a high school textbook. Absolutely. They're written, and it's been, there are better and worse ones, of course, but by virtue of the fact that the textbooks have been through this filter of kids either saying this is a good textbook, this is a bad textbook. Textbooks today are so much better than they were in the past, and they continue to get better over time. I mean, they could be better still, but you know what I mean? One of the few areas of schooling that shows objective improvements over time. Science texts, maths texts, with some steps back, as I say, 2 steps forward, 1 step back now and again. There is politics being injected into certain textbooks now. But that aside, broadly speaking, if you want to learn any of the sciences, you want to learn mathematics, these areas, then yeah, school textbooks would be a way to go. Let's see. Spell Solo, how to be wealthy. I don't know. That's a question for Naval Ravikant. He's written, his book, Naval's Almanac, or his podcasts, or the Twitter thread, How to Be Rich. I would go to that. I am no authority on that. I hand that over to someone else. F the Bald Guy has asked, what are your current thoughts on cryptocurrency? Are the ups and downs simply the normal behavior of any system going through evolution? Yeah, it's here to stay. It's here to stay. It's here to stay in the same way that computers are here to stay. And naysayers are the same. You always get naysayers with new technology. It's proven itself now. Crypto has proven itself. There is a critical mass of people. Sufficient numbers are out there now that, there's been a downturn, but there's been a downturn across the financial markets thanks to poor policy decisions. So everything's turned down. Crypto is one of those things, but it's not going anywhere. It's not going anywhere. Sure, some of the coins, the crappy coins are going to go, shit coins, but the generally speaking, Bitcoin and I'd say Ethereum are absolutely here to stay. Blockchain technology is here to stay. People want currencies that allow them to escape, as Naval says, allow them to escape from the Fed, allow them to escape from authorities that can intervene in transactions. Instead, we have peer-to-peer financial transactions possible now with this thing that no one else has to know about. So this is the way things are going increasingly. Sure, in reaction, governments of the world, authorities of the world are reacting. But there is this great struggle now between authoritarianism and libertarianism. The libertarians aren't going anywhere. They might suffer defeats here and there, but they're not going to approach zero asymptotically. In the long run, I think it's the only way to go is individualism. And that means things like crypto. So yeah, crypto is just the ups and downs are, yes, the normal behavior of any new system. Yes, going through evolution, but it's absolutely here to stay. Not because it's a get rich quick scheme or anything like that, but because it's a way of storing value independent of existing mechanisms, where especially third parties can intervene, in particular governments. That's what some of us like about this thing anyway. That's the main reason for it. That's the main reason for it. Okay, now. Every way of storing value has problems, okay? You can store value in gold, you can store value in a house, you can store value in goods and whatever. They all have liabilities. Crypto has liabilities, but it's a method of storing value. That's all. A big, sort of big deal in a sense, but revolutionary in the other sense. That is, it's far more on the side of individuals and creativity and independence and anti-authority and liberty and so on. All that stuff. Yeah. Jonathan Hirsch, is there anything Deutsch has wrong? He seems spot on with nearly everything he says. I agree. I think I had this question last time. My response was, I think David Deutsch, he likes a cup of tea, but he likes tea bags. I don't know if I'm speaking out of school in saying that, but I like the leaves. I think he's objectively wrong if he doesn't like loose leaf tea over tea bags, but that would be a question for him. I think he's objectively wrong on that. Yeah, no, but in terms of the serious point, well, this is why I promote the ideas and why I think it's important to do so, is that I wouldn't do it if David Deutsch was super, super well known. If he had, 50 million Twitter followers, this was probably a lower bound on what he should have, then I wouldn't need to do what I do. But because his work is relatively unknown, it's well known by some physicists who work in the area. It's well known by people in a certain community. But broadly speaking, it's not as well known. It's it is the philosophy of optimism, his work, the philosophy of progress, incremental progress, error correction, knowledge creation, solving of problems, all of that. Why it hasn't received the traction it has, I don't know. Some of the ideas are subtle, but the more people that can be out there approaching the countering, as I like to say, the countering of the dominant culture, which is a pessimistic culture, the better. But within the people that counter pessimistic culture in a rational way, okay, so you've got the intellectual class, I suppose. The dominant strand of the intellectual class are far and away pessimists, right? And so you've got this small number of people who are optimists and pushing back against the pessimists, but they're small in number. It's probably like a 1-to-5 ratio or something like that when it comes to intellectual life. I mean, just pick a podcast, not mine, pick a typical podcast that interviews people, and then look at the list of intellectuals that you have on and listen, add up how many pessimists versus optimists, how many people are saying all the ways in which civilization is going to hell in a handbasket, all the people who are saying, here's all the ways we're going to die from alien invasion or AI apocalypse or climate change catastrophe or genetic accident or virus, whatever. Now compare those people to the optimists. Okay, I think it's like a 1-to-4, 1-to-5 ratio, something like that. But within that group of people who push back, an even tinier percentage of those are aware of David Deutsch. Or insofar as they're aware, they're not really all in on the worldview, as we call it. There are optimists out there, but to take people who are very closely allied, Steven Pinker, okay, great optimist. But there's pessimistic stuff in his work. The very next podcast, which should come out tomorrow, I think, is about the next chapter of his book. I think it's chapter 5, subtitled Bayesian Reasoning. And it's that kind of reasoning that leads to people becoming prophets, thinking they can prophesy, and therefore they tend towards pessimism. So the intellectuals, their dominant epistemology is one which naturally gravitates towards prophecy, which itself naturally gravitates towards pessimism. So this is the problem we have in intellectual circles. And so, the community of people promoting the work of David Deutsch occupies this tiny, tiny sliver of optimists, generally speaking, which itself is a very minority view amongst all intellectual movements that exist and that have any kind of influence on things like politics and things like culture at the moment. Far and away, we are dominated by pessimism. Nature lover. What's importance of probability in physics and real life? Not important. See my podcast on probability, risk and reward, that kind of thing for this. But probability was invented to understand the results of games of chance, okay? Rolling dice, playing cards, gambling. But even there, it's only an approximation to what really happens. So that's the first thing. The fact that it was then taken from that very parochial thing about how gambling works and applied to wildly diverse areas, like how to assess risk, how to understand quantum theory, financial markets. The fact that it was used as a model for all of those things, great mistake, great error. It doesn't track physical reality at all. And so I've done podcasts on this. David Deutsch has done a lecture on this. So I've done a podcast breaking down the lecture. Probability is a scam. I think David has said it at some point. Nothing actually obeys the probability calculus, not even the things in a casino. They only approximately do, but that's not reality. It's kind of like Newtonian gravity. Now, can you use probability to make some decisions? Yeah, like should you place a bet on the lottery? No. Why? Because the probability is exceedingly low, approximately, of you winning it. You shouldn't gamble. But, your problem situation might be just to have fun, okay? I have been known to gamble with my brothers now and again. It's fun. It's just fun to do. What else have we got? Paul Eloff. Hi, Brett. Do you plan on recording a deep dive into constructor theory papers? I would personally enjoy to hear someone else's thoughts as they go through these papers, CT Life in particular. Oh, look, maybe after I've done Chiara Marletto's book, The Science of Can and Can't, once I've completed that, I think I've got another chapter to go on that. So that serves, I think, as a reasonable introduction to constructor theory for the layperson. I'm a layperson in all of these things. And there are a number of good interviews out there with Chiara, in particular, her collaborators. Logan Chipkin is someone who has interviewed Chiara and has a podcast out there with her. I think Sean Carroll interviewed Chiara about constructor theory as well. So there are some good interviews out there with the people working on it. And I think they've broken down some of the stuff very, very well. So what I could add to that, I don't know, beyond what I already have, but never say never, I suppose. So yeah, quite possibly. New England Barbell. Hi, Brett. What is or was the most mind-bending, mind-expanding concept that you have tried to comprehend or comprehended? What is the most mind-bending thing? I don't know about most, but I know what the experience is like of mind-bendingness. And I remember when I think the first time I felt it, you go through school and you're learning stuff that everyone else is learning. And so I can't remember. I guess my mind must have been blown at various points throughout school and learning about the universe, even when I was very young, 5, 6 years old or something. And so you have this experience of, oh, there's more than just a planet. Oh, there's a universe, and the universe might go on forever. Maybe that was mind-bending, but I don't remember. I remember reading Descartes' meditations in the first year of university when I was like 17, 18. And I remember the sensation of understanding for the first time what he was saying about you can doubt everything. And that was phenomenal, because up until then I'd had the experience only of, well, you can find out that certain things are true and you don't need to doubt them anymore. But Descartes explains in the meditations you can. And it was like the floor falling away from underneath you when you begin to feel as if, wow, a lot of what I previously thought has just come into question. And then he has this profound thing of, but in the act of doubting, you exist. And so that's the one thing you can't doubt. And I thought, wow, that's amazing. Now, of course, I reject that now. Now I have criticisms of Descartes, but at that point, it was a profoundly mind-bending, expanding experience. It was fallibilism almost. He just didn't go the extra step. And so then, the next time I had that experience, was because I was going through university learning quantum theory, among other things, but quantum theory in particular, and just struggling to understand what the heck does any of this mean. The lecturers weren't helping. Even my great hero, Paul Davies, wasn't helping. Reading his books wasn't helping. And I've told this story many times. I picked up The Fabric of Reality, got to chapter 2, read Shadows, and there it was. I mean, there was the explanation of what's going on in quantum theory, in the interference experiments. Suddenly it was clear. Exactly what the day was and the moment was, I don't know. I just remember the sensation was exactly the same as I had with Descartes, because I immediately understood, oh, quantum theory implies a multiverse. Mind expanding, mind bending stuff. So whether or not that's the most, but those two things stand out in my mind. And I've had that, again, you read the beginning of Infinity, you have it again, in various ways. You coming to understand something that totally shifts your worldview in some way. In the case of quantum mechanics, mind expanding, because you realize, wow, okay, so every possibility really exists out there in some way. That's the multiverse. That's what quantum mechanics is. And that makes sense. And then realizing, well, that's astonishing. But also at the same time, well, it's just the latest step in the trend that's been going on in human civilization, coming to understand our place in reality. We live on an Earth. Well, the Earth is actually part of a solar system. Well, a solar system is part of a galaxy. Galaxy is part of a wider universe. The universe is part of a multiverse. Okay, so yeah. So although some people reject it, I just think, well, it's the next step, but still mind-bending. Okay, so that's where we are with that. Hello, is the world more or less dangerous when everyone has a universal constructor under their mattress? Cheers. Less dangerous, much less dangerous. Whatever the bad thing is that people might do with universal constructors, the argument applies for any other technology as well. So that if the bad guys have a universal constructor that can create the virus, presumably the good guys have a universal constructor that can undo it. And better than that, they have a universal constructor that can work faster. Okay? I can imagine there could be, universal constructor is just that thing that can build anything that's buildable. But I presume there would be different speeds. There'll be higher and lower quality versions of them, right? Like computers. Computers operate at different speeds. Now the bad guys are using their old, Windows machine over there. And the good guys are using the equivalent of the Apple universal constructor. So, who knows? Yeah, something like that. So yeah, I would say the world is going to be less dangerous because universal constructors will solve a whole bunch of problems that would otherwise cause us great danger. Thanks, Mason. Mason said, keep up the good work. John Ortiz, besides Karl Popper, what other philosophers are worth reading? Well, Gosh, again, it depends on what you're interested in. Now, Popper is far and away the best for just broad-based understanding of stuff. But like, I do like Spinoza, although it's sort of metaphysical kind of stuff. Like, worth reading, there's a lot contained within that. Sort of, if you're interested in the history of philosophy, as I am, Wittgenstein is worth reading because almost everyone in professional philosophy thinks he's one of the greatest geniuses of all time. I don't, but you got to give the man credit for capturing the intellectual zeitgeist, so you better understand what he's trying to say. I think I understand what he's trying to say. I'm not that impressed, but other people are. So yeah, worth reading for that reason. Descartes worth reading. Hume is worth reading. Leibniz is worth. Okay. Modern philosophers. I like Ayn Rand. I think that she's wrong on certain things, but I don't think there's many better defenses of capitalism and individual liberty, for example. I think she's wrong on epistemology. I think she's wrong on aspects of morality, the importance of institutions, traditions in particular, actually. Tradition is very important in maintaining stability while undergoing rapid progress, as we talk about here a lot. And I think Rand got that wrong. But, all that aside, I think that's worth reading. Dark Goat, his philosophy is very optimistic, speaking of optimism. Matt Ridley, The Rational Optimist, is a very interesting book. What are your thoughts on Matt's views? Yeah, very good. I think that he, like Pinker, is very, very close to David Deutsch. It's just that, he wrote a whole book on this. David Deutsch also written a whole book on it, but really, there's that chapter, it's chapter 9, Optimism, that really explains what's going on, and David Deutsch has the deepest exposition of optimism, the way in which it's connected to knowledge, physics, morality. That's deep. That's the fundamental explanation of what's going on with optimism, that problems are soluble. All evils are due to insufficient knowledge. So therefore, you got evil, you got morality. Knowledge, you've got epistemology. What can be known, what can possibly be known, is physics. Optimism brings all these things in. The fact that you can solve problems at all is optimism. Okay? And if it's not prohibited by the laws of physics, then all you need is the right knowledge. Okay, so this is the fundamental understanding of optimism. So I think Matt Ridley is great. I think that just it's emergent special cases of optimism. And it's almost like I don't want to say self-help. It's not. I don't want to reduce it to that, but it has a less cosmic kind of perspective. I read the book only once, and I just thought, yeah, I agree with all this. Yeah, there was nothing that I found that I, off the top of my head, I particularly disagreed with. It's been a while. I read it soon after it first came out, and yeah. So Matt Ridley, great optimist, but I like the deepest explanations, which is what Deutsch gives. Yeah, it's kind of the same thing with Pinker provides often 15 different examples when 2 would have done in some of the books, books about how, things are getting better over time that Pinker has written. And it's like, well, yeah, they have, you can make that case, but you read it and you go, well, yeah, but what's the deeper reason? What's the really deep reason why things are getting better? Things are getting better. Yeah, you've established that. We can agree. In fact, you made the point 4 chapters ago. You're still making the point. Things are getting better. What's the reason? And I think you find the reason in the work of David Deutsch, why it is that we have this progress going on. Not inevitable, but incremental. And explanations as to why it should continue in a dynamic society. Yeah. Okay. Tiesto edit. Why read books at all if you can discover the answers that matter inside of yourself? Because it's more efficient to begin with some background knowledge that's been tested. Rediscovering things for yourself from scratch means you can only make a lifetime's worth of progress. But what you want is to make progress on top of all the lifetimes that have preceded us, don't you? You want to stand on the shoulders of giants. When you read a book and you take on the knowledge that's in a book, you are actually recreating that knowledge. And you may very well recreate it in a slightly different way, an adapted way, an improved way. Could be worse, could be improved. But that's what people do. When they come to a book, they bring their ideas with it and they can change it. And when they go and explain it to other people, they can change it in better and worse ways as well. Okay, there's no method of communication that's without ambiguity, as we say. It is not possible to speak in such a way as you cannot be misunderstood, as Karl Popper says. And so, yeah, it's no good just discovering the answers that matter inside of yourself. If you want to make progress, if you were just to start from scratch on every single thing, expect to make as much progress as, the caveman did. We're not cavemen. This is why we have libraries and knowledge and stuff, so we can build upon and not just start from scratch. Not build upon nothing, but build upon something. Todd Abrams, what do you mean when you say monopolies are the only possible when enabled by the government? I think they're so-called natural monopolies. There are natural monopolies in the markets when someone invents something for the first time. I'm just going to have a little bit of my milkshake here. So this was made by a blender, right? And so the first person to ever make a blender, an electric blender, had a monopoly on the market by definition, because there were no other blenders had been invented. Same is true of the iPhone, the smartphone, right? It's my smartphone here. Apple came out with the smartphone first and had a natural monopoly for what? A year or two? I can't remember the history of this, but it wasn't long before Samsung came out with a copy. There is no situation in which a monopoly can be entrenched unless government gets involved, because then force can be used, literal force. Guns and strongmen can come along and say, you can't do that. You can't sell that thing. That's the only time you have a monopoly. I think, less and less in Australia now, but I'm pretty sure in Australia, letters, it might be the same in America and the United States, but letters to people's houses, like you write a letter, put it in an envelope, send it to someone. The only one legally able to deliver that letter, I think, is Australia Post, our post offices. You can have couriers and stuff, but that's different. So I have a monopoly. There are various monopolies instantiated by government. I think the government needs to be a monopoly on violence. There should only be one police force. There should only be one military. But for everything else, things work best when you don't have force being used. And although there might be situations where, like with Google, let's say, a particular service or good is provided and persists over time for a long time and basically dominates the market. Google is not a monopoly. There is Bing and there are other things out there. Now, are they anywhere near as dominant as Google? No, not at all. But if the history of the internet shows us anything at all, it's that anything you think is going to stick around, Netscape, IRC, ICQ, there are just so many, MySpace, anything you think is going to dominate the market is not going to forever. I don't think Google's going to be around forever. I think another search engine will come along, absolutely. How long will it take? 5 years, 10 years? I don't know. But Google does not have the power, the authority. Like when I say power, I mean the literal capacity to bring strong men to your house and shut you down and put you in jail or fine you for not using their service. The government does. The government does. The government can create monopolies in that way. Okay. Yeah. So, okay, I'm just going to triple check might call it a day here, but I'll just triple check my Twitter feed and see if there are any other questions that have come through. Okay. Likesh has asked. What I'm trying to wrap my head around, he says, is that if the other verses in the multiverse are essentially copies of our verse, then doesn't it mean that evolution in those other verses took place like for exactly the same way as our verse? So all the small details happen in mutate. What's going on right now is that for any object and for any universe, there are uncountably, infinitely many fungible copies of that thing, which means absolutely identical copies. And when a choice is made or a quantum event happens, the object and hence the universes differentiate. There are uncountably infinite number of universes where evolution took place exactly the same way as it has here on Earth. But there are many, many more universes where evolution didn't take place as it did here. Many more. Because the mutations would have led to other structures. Yeah. So that's what I would say about that. Do I have any video or source that talks about this? Well, if you've watched or you say you haven't watched all of my videos about the multiverse theory. Well, I haven't connected the multiverse theory directly to evolution, I don't think, but it's just a special case of things that could have been otherwise. Whatever is physically possible in evolution by natural selection actually happens somewhere in the multiverse. The ones that are most resilient, the most resilient forms of life are the ones that are going to be most common throughout the multiverse. They occupy the greatest measure of universes. So that's one way to think about that. But yeah, beyond that, I don't have anything else to say. What else have we got? I think that's it. I think that's all the questions. Yeah, what are your current thoughts on cryptocurrency? Yes, I've answered that. So unless there are any final questions, I think that's it. That's nearly 2 hours, which I think is pretty good for today. Hopefully I can figure out how exactly to set up a live stream in advance so that when I go back in, it's a very easy process of starting the live stream, because today that didn't work. I provided a link to the live stream and thought, okay, I'll set it up. I've done this before. I did it the other day. I trialed it twice. It worked. And then this time I go in to try and start the thing and there's no button that says start. So still a noob, not efficient enough on this thing. Okay. So, yeah, until next time, I suppose we'll end it here now. I don't know when I'll do another one, but look forward to the next podcast, which is going to be, well, me trying not to be mean about the way in which Bayesian reasoning is used by so many intellectuals and Steven Pinker's view of rationality. But increasingly, my exploration of that book is becoming more and more a critique than anything else, because sometimes I don't know where to begin because it's just so wrong in so many ways. Human beings are not Bayesian reasoners. Induction is not a thing. And thinking that you can base rationality on it is terribly wrong and misguided. And so the next podcast is that me trying to politely explain the ways in which this is a deficient, limiting view of rationality. Okay, but until the next live stream, see you later. Bye-bye.